Live, and let's talk about this a little bit. Let's have this conversation around mathematics and when it actually began. When did mathematics actually begin? So I wanted to kind of come and talk to you a little bit about that because I think it's an important subject. And it's important for us to think about, right? As we start to think about a lot of things that have happened in history, a lot of times, we may ask ourselves questions, when do certain things happen? And we study history in school and in various places in education by just looking at a limited amount of history. We literally look at, less than 2% of human history. When you think about human history really being as millions of years, a story of millions of years, and even beyond that, if you look at the life of the earth, and even you look at Homo sapiens sapiens, just like you and I, you're talking about hundreds of thousands of years of history. And we literally only look at maybe 2,000 or 3,000 years of history, and maybe a little bit more than that. And we focused on certain areas, certain civilizations, and not much beyond that. And we don't talk about the breadth of human experience. So I asked myself the question, when did mathematics really start? When did math really start? As we think about mathematics and thinking about it as a way of people using numbers and numbers systematically, or numbers in a way to solve problems, to approach issues or challenges they may have to help make their lives easier. So when we think about it like that, mathematics has a long history. And I want to talk about that today as we kind of jump into that and talk a little bit about math. So I hope that you are doing well. God bless you. Hope all things are well with you. And I hope that you get a chance. If you get a chance, take a look down below and just, leave some comments. If you have comments you want to leave, you have some things you want, suggestions you want to make, please feel free, because I know there are a lot of good people with a lot of good comments down there and probably have a lot to contribute to this. So please feel free to share your information and your comments, and I'll put some down there as well. So I start to think about that, the whole idea of math and when did math start? And because we put so much emphasis, we put emphasis on things like writing, right? And we'll say writing started in, literally like 3300 BC, 3100 BC, and we'll say it started in Mesopotamia and in ancient Kemet. And we'll say that, and we make it seem as if it is only those societies and those areas that we could focus on, and those are the things we study. And when you really think about that, and at that time, people are all over the world. 3,000 years before Christ, 3000 BC, people are all over the world. They're all in South America, they're in North America. They've been on Australia, on the island, the water surrounded island, if you will, continent, if you will, a continent of Australia, but it's surrounded by water. They're on the whole area of Australia, and they've been on there for thousands of years. 3000 BC, they had been there 50,000 BC, maybe 60,000 BC. They've been in Australia for a long period of time. People are in Asia. They're all over the world in 3000 BC. But we choose to look at that as a way that we're going to study these civilizations. And we only study these things with respect to, this is when we say writing started, although I believe writing started before then. Any type of communication, when you draw it or you write it, is communication through writing, I believe. And also, it's interesting, even though we'll point to this part of the world as being the place where writing started, and when we look at things, we don't give them the breadth of acknowledgement when it comes to mathematics, right? When we talk about mathematics and other forms of science, we seem to skip over this part. We point to them and say, hey, they helped to start writing, we say, but we don't talk about them when it comes to math. It's very interesting how we just skip over ancient Kemet. We skip over a lot of things, a lot of places around the world, and we go straight to Greece. Even though we know there's a period of hundreds of years, now we'll be talking about that soon, hundreds of years of interaction between ancient Kemetic people and Greek people before Greek emerges and Greece emerges as a powerhouse in that area. So they literally have hundreds of years of trade and interaction and influence. Frankly, so when you think about things like Pythagoras, they're studying in Egypt. They're studying in ancient Kemet at a time when mathematics had already been old in Kemet. But I want to even go beyond. I want to think about that whole idea of math and how do we look at math, and some ways we can talk about math, and then how do we join that? Because it becomes significant, I believe, to begin to enjoy what people had to contribute, and not just from a limited standpoint, but really looking at the whole breadth of information and whole breadth of mathematics. And I'm going to talk a little bit about mathematics in Egypt, and I'm going to put some of this resource that I have here, I'm going to put part of that in the page, in the download section for those who are members of my site. So here on YouTube and Facebook, thank you so much for being members. I'm going to put this so you can have access to it. So this will be there for members that we'll talk about. But as we start to frame up for ourselves, when did mathematics get started? Like, who started math, and when can we look at that? We kind of have to go back and look at just ancient things in general. And as you kind of look at this right here, I'm looking at this particular timeline. As you guys know, I've been working on a timeline and using that for some time now. You look back some 50,000 years ago, you can see in 50,000 BC, there are people in Australia. So there are Aboriginal people in Australia tens of thousands of years ago. And even when you go back there, you can start seeing artifacts that you can find even in parts of Southern Africa, where you find tools and bones that were used as probably calculating devices where it was clear they were marking something, they were numbering things. So you start to sit back and for a second and just think where you might be in the world and how things might be developing when it comes to math. You start to understand that a lot of things are happening in mathematics that we just aren't talking about. So as I start to think about that, and we kind of put ourselves, way back in the day where we were maybe looking at parts of Africa where we are in a situation where it's tens of thousands of years ago. And you can imagine if you're in a situation where you have, you're in a grassy land, you are tens of thousands of years ago. This is long before ancient Kemet, long before Egypt, long before Sumeria, even long before Kush, long before all of the societies that we talk about. They're people. And for a long period of time in human history, people spent the time on the African continent. Homo sapiens spent a large part of their development, our development on the continent of Africa before we moved out. And even the hominins and the people who are predecessors to humans spent time on the African continent before they moved out. So you have a large period of time spending on the continent of Africa. And stop for a second and just think about it. If we think about just the dynamics of it, you think about the dynamics of 70,000 years ago, 75,000 years ago. You think about the dynamics of being in a situation where, and people talk about this life a lot, where you may be a woman and you're having your menstrual cycle, you're having something like that. And you are, if you had something like that happen, obviously you're going to be somewhat surprised. But by this time, people know this, right? Women would have known this. This would have been something that would have been passed on from woman to her daughter to daughters, so that when this happens to you, you're not freaking out. You're not thinking, oh my gosh, there's something wrong with me. You're not scared. People probably took you aside. Women probably took other women aside and said, no, this happens, and it happens periodically. It will come back. And, you can even probably look at the sky. You could probably look at the nighttime sky. And you can probably see things that you would notice there that you wouldn't notice in other ways. You could probably count the cycles of the moon. You could probably count, when certain things were developed versus other things, when certain phenomenon appeared, because you have various recyclings of the moon, so to speak, to determine when this might come again. You would have an idea of cycles. You would have an idea of time. You would have an idea of periodic things happening to you, especially if you're women. But not just that. I think about it in terms of womanhood and motherhood. And we're going to look at very simple, simplistic examples. Imagine you were a mother of 3 or 4 children. Maybe you had 4 or 5 children, and you were going out, or your mate was going out, and you got food, and you would automatically, without any type of instruction, you would automatically want to know, do I have enough for each of my children? Do I have enough for all 4 of them? Whether you use the word for or whatever type of concept you have you had to represent that number and that idea, you would know you had 4 or 5 children. You would know how many children you had. You would know how many mouths you had to feed. You would know if you were traveling from one place to another, whether or not one was lost. You would understand these things. If you were gathering resources to take care of your family, you would very quickly begin to understand, I need a certain amount of resources to take care of each person in the family. The whole idea that people began to think about math and to think about things like that. And it wasn't until 3000 BC, or it wasn't until the Kemetic people. It's ridiculous. We know that there's the Shango stone. We know there are artifacts found in Southern Africa that are literally tens of thousands of years old, dating back to maybe some 70,000 years ago, 75,000 years ago in Southern Africa, and in places like the Congo, tens of thousands of years, where there are artifacts that are found. And these are just the things that were found. So when we start to think about just history, and just a timeline of history, if you will, these are just the things that were found. These are not just the things that may have been there. These are things that were found some thousands of years ago, tens of thousands of years ago, that support and look at people using mathematics, using numbers and counting and conceptualizing their world in a certain ways. Now, obviously, some of the archaeological finds are going to reveal some things, and there are going to be some things that we will never know. There may be some things we'll never find when it comes to mathematics. There may be some things that we'll never find because it happened 70,000 years ago. mean, human beings have literally been on Earth for hundreds of thousands of years. There's a lot of stuff that we've done that may never be recovered. They may only literally be in our DNA. They may only be literally in our memory from a DNA perspective, and not something that we'll be able to recover. And hopefully in the future, there'll be more things that we will be able to uncover. But we also have to apply very simplistic and things that make sense, very common sense ways of us looking at Africa and looking at people around the world with respect to the science that we practice now and the sciences that are now a part of our lives. These are not things that just developed in the past few hundred years by just people in Europe, by just European people, and nobody else had contributions to it. That really is not the case. In all likelihood, more than likely, our ancestors from tens of thousands of years ago began these sciences, began these observations, began the use of these techniques because they had to, because that was the dictate of the environment within which they were living. They had to do that. And so appreciate it. Thank you. Babylon, how you doing? And JB, how you doing? Thank you so much. God bless you. You have thank you. Yes. You end up thinking and beginning to apply, common sense to a lot of the stuff that we're doing. It's so funny because as we think about math and we think about science and we do a lot of things, a lot of times we are asked to apply common sense when it comes to science. If you take a science class now, you take a math class, they're going to ask you to apply reasonable thinking. They're going to ask you to come up with a hypothesis and to go through the most likely answer. The only time they stop doing that and they don't want us to go through the likely answers is when we start to talk about other people contributing to math and science. Then we kind of lose our common sense. We lose that whole idea that maybe other people had contributions to math and science other than Greeks and Romans. So we literally point to Greek people who were beautiful people, nothing wrong with the people who lived in antiquity, but they were living in a time where they interacted with people who were already practicing mathematical techniques for thousands of years before the Greeks even emerged as a city state, if you will, and their city states even emerged as they emerged as the powerhouse. And even long before the people that they were interacting with, the ancient Kemetic people, they were human beings on the earth for thousands of years, hundreds of thousands of years. There's no way we went around without using math. There's no way we did not use numbers and counting and systems to help us be able to make our lives easier. So as we start to think about that, you have to apply even the scientific method and common sense to this. And the reason why I say this and I share this information because I think it becomes very important for us to reject the types of things that people are telling us that just tells us that one group of people contributed to humankind. I think we have to reject that because if we reject that now, and if we reject that as we teach our children, we can grow up with a whole generation of people respecting themselves, respecting other people, respecting the diversity that is humankind and everybody that contributed, knowing that that makes no sense to say that the first people who considered things about geography or geometry or people who were Greeks. When you know absolutely that they're pyramids and pyramidal structures that had to do with area and volume and the base and the height of triangles and pyramids already being in place long before Greece becomes a powerhouse. And so it becomes important for us to reject that and even beyond that because we take away the people who lived before them. We just almost either don't study them or just don't talk about them. And in the artifacts that have already been found, and like I mentioned in South Africa and in the Congo with respect to bones and mathematical instruments and tools and resources are just a very tip of the iceberg of what our ancestors must have done. And so as we start to think about this, it becomes important for us to know that not only would you have had motherhood, not only would you have had people going out to find food, if you will, you would have had, as people began to form social groups and society moving forward, you would have had a need to be able to count. You would have had a need to, in some way, to be able to assess time as time went on, because obviously people would live and die. You would have to be able to assess weaponry. If you went out and you got weaponry, or if you went out and you fished and you went fishing and you were able to harpoon or catch fish, how many did you catch? And you would very quickly, without any type of quote instruction, you would very quickly be able to assess, did we catch enough? Do we have enough to feed the people that are there? Right. And it's almost like we think people just walked around and twirled around for tens of thousands of years in Africa and didn't understand these things. If they didn't understand these things, we wouldn't be here. There would not have been a human race. If we didn't apply the intelligence that came with being Homo sapiens to our everyday living, like I said, fishing and being able to get food or fashioning tools. If you fashion tools and you went out to maybe hunt or maybe to fight someone else, you'd want to know if you had a tool for every person. You'd want to know if you had a weapon for every person. If people went out and you didn't have enough weapons, you might be in trouble and you might be in a disadvantage. You would figure that out long before. So the idea of math, the idea of counting, the idea of resources was around a long, long time before there was an ancient Kemet, before there was in Egypt, before there was a Sumer, and I believe, all over the world. But I know also in Africa, because you have human beings, Homo sapiens, just like you and I, in Africa for hundreds of thousands of years, literally hundreds of thousands of years, people are in Africa. I mean, you have 300,000 years of information and documented information of people, human beings, Homo sapiens, just like you and I, same abilities, just like you and I. We were just living off of the accomplishments and the wills and the doings of our ancestors. But you have Homo sapiens, just like you and I, in Africa for for 300,000 years at least, and for a long period of time before they left. And even before you go beyond that, there are millions of years of information, records, and documentation, and bones, and artifacts, and archaeological evidence that show that there are human beings and Homo sapien ancestors in Africa for millions of years. And so as we start to think about our history being millions of years long, not 10,000 years long, not 2,000 years long, the history is millions of years long, then you start to say, you know what? This whole idea about mathematics, this whole idea about science, it could not have started 2,000 years ago. It could not have started with the Greeks. And there's no disrespect to the Greeks. It could not have started. What you're dealing with is situations where people came in contact with other people who were already doing these types of things in their own ways, with their own value systems, with their own mindset applied to it. And other people, as we do today, you find people do things, you build on it. And we just have people who build on top of the knowledge that was already there. Even when this gentleman lived, even when this depiction of this person lived, thousands of years ago, some 4,000 or 5,000 years ago when this was made, long before this gentleman, long before this depiction was developed, people were doing artistry, they were doing math, they were doing science. And that's why I believe, and you can tell me what your thoughts are, that's why I believe that when you begin to think about math and you think about writing and various things in ancient Kemet, that's why you find ancient Kemet starting its country and starting the unification of the two lands with writing already in place, with a lot of the religious systems already in place, with the idea of mathematics being very well developed when they start a country. How is it that they have these things develop and can start their country almost immediately with administration and taxes and agriculture and distribution of wealth and distribution of resources without mathematics being already developed? And it wasn't just developed in the Nile Valley and in the Fertile Crescents. It was developed in various places around the world, not just in Africa, around the world it was developed. So I wanted to make that point because I think it helps us have a better idea and helps our children have a better idea of who we are and things that are important. If our children understand that, they wouldn't have so much disrespect for themselves and maybe for other people. So I want to kind of jump into some specifics about mathematics in Egypt and ancient Kemet, just to give us an idea of a different way of looking at arithmetic and fractions and things, if you will. And they had, and just to give us a picture of it, right? So we understand that it's long before Kemet, the whole idea of math and the whole idea of people using numbers to help them solve problems and using it in a systematic way was long before ancient Kemet. And it may be lost in history, but we know there's tens of thousands of years of artifacts or artifacts that are tens of thousands of years old that help show us that help give us an indication that people were doing something with respect to numbers and maths and even observation of the stars and various things like that. Number of things to make things significant with them. But as we kind of jump forward and go about 5,000 years ago when we started to look at ancient Kemet, let's look at some of the things they did with respect to their symbols and with respect to their whole mathematical system. And they had a decimal-based system, if you will, a system based on 10. And they had hieroglyphics and symbols and writings for, numbers 1 and then 10. And then they would have symbols for the powers of 10 on up to 1,000,000 after that. So as we take a look at to kind of give you an example of that, let's just kind of take a peek. Their symbol for the number 1, if it was just a single stroke, and I'll kind of make myself a little bit gone there so you can see that. So the symbol for the number 1 is just a single stroke. So you just essentially have the single stroke as number 1. The symbol for the number 10 is interesting to me, and it gives me an indication of why I know that the mathematics for ancient Kemet and mathematics goes back farther than ancient Kemet and just that area of the world. The symbol for 10 is like an upside down U, which we'll see more of examples of that. You kind of get an example. It's like an upside down U. It was literally like the symbol for a hobble for a cattle. And it was like an upside down U. And so when you think about that, the hobble for a cattle, what is the hobble for a cattle? What does that even mean, right? So when you start to think about that, as you start to think about it, cattle were basically a symbol and the basis of wealth, especially in the Nile Valley, especially when there was the Green Sahara, when there was a grassland in the Nile Valley. And even as the Nile Valley dried out, you had cattle were very significant. They were significant in the ability for you to be able to eat, for you to be able to have some type of source of nutrition, because obviously you can milk your cows, for you to be able to have almost like a walking grocery store. And in a lot of ways, as we've mentioned, as we talked about Nabta, Playa, we've talked about ancient Kush, we talked about Kerma, we talked about Kataru or Hathor, we've talked about ancient Kemet, and the use of and the images of cows and bulls and cattle in general, and how significant that was long before Kemet became Kemet, but in particular in this area as well. So you start to see that cattle represent wealth. They're representative of deities. They look at God being manifested as cattle, so whether it's the king referring to himself as a bull, or Heteru being in the symbol of a cow, if you will. Cattle are very significant. And you can have, if you know, I don't know if you're a farmer, because I'm totally not a farmer and I've never been farming, God bless you. China and India especially, right? So you have a whole lot of people. I think all over the world they were doing things with math. Very good point, Tarakli. I think you have a lot of people were advanced. I think people are people, right? People are advanced, and we just don't think about it. We don't study it. But as you were looking at, if you were dealing with cattle back in the day, and people even do this to some extent today, they have like a little thing called a hobble, and you can look it up. It's a little thing that you can tie around the legs of a cow or calf or any type of cattle that will help you stop them from kicking. So let's imagine if you were milking a cow and you were trying to get milk out of the cow, and maybe that cow was irritated by something and started kicking. That might be difficult for you to be able to milk that cow. It might be dangerous for the other cattle nearby. It might be dangerous for you. Maybe you have a bucket or a piece of pottery where you've put the milk in and the cow could kick it over. So that cow moving, it would be kind of difficult. So you had this hobble that you would put around the cow to basically hobble them and to stop them from kicking. Well, that was the symbol for the number 10. Think about it, that was the symbol for the number. Why would they make 10 be referred to the hobble of a cattle? To me, when I started to think about it, and I started to think about numbers, and I started to think about mathematics, you start to use symbols that mean something to you, right? So the whole idea of cattle being significant, being important to wealth, being important for your survival, being important for a number of different reasons, then the number 10 becomes something that's bigger than one, something that becomes to be the basis of what you're doing, something that becomes to be significant. So you start to see the number 10 represented literally by a hobble that you put around to tie up a cattle to stop it from kicking. And that is like an upside down U. And so then you start to have them also have a symbol for 100. They have a symbol for 100, a symbol for 1,000. As you go up to powers of 10, up until 1 million, they have symbols for that in the Kemetic mathematical system. So you have 1, 10, and symbols for powers of 10 going up to 100 or up to 1 million. So you have them dealing with large numbers. They're not dealing with small numbers here. They're dealing with large numbers, and they're dealing with numerical symbols. And just to give you an idea, if you can see right here, I'll kind of let you be able to see, how did the ancient Kemetic people write to number 23, for example? How would you have written that? So the number 23 would be 2 10s. So our two of our upside down U's that represent a hobble for cattle right there, 2 upside down U's, 2 10s, and then 3 1s. And they would have grouped that together, and that would be the number 23. You would have 2 10s and 3 1s. And then you start to see them do something even more significant and deeper than that. As you start to look at, let's say you had the number 5,432. Well, they would represent that with 5 1,000s. Understand I have 5,000s, right? And the symbol 4,000, and then 4 100s. And then you have 3 10s and 2 1s. That's how they would draw their numbers. It's similar to the number 23. So they would draw their numbers like that. And just to give you a picture of what these numbers look like, so you can take a look at it on the screen, that's the example of their numbers right there. You can kind of take a look at that and see what those numbers look like on the screen. So you see the number 1 here. You see 10, that upside down U. You see 100, which is kind of like a rope that's coiled around. You see 1,000, which is kind of like a lotus flower. 10,000, which is like a finger kind of pointed to the left. You see 100,000, which is kind of like a tadpole and a frog-like figure, which is very interesting because, maybe they're thinking about the way in which tadpoles multiply and become and transform, right? So So you know there's more to, or maybe it has something to do with the way in which they said the numbers and the way they said the word for tadpole or frog. A lot of times they had connections with the words they use, and they use symbols for various reasons. So this symbol for 100,000 is like a tadpole or frog-like symbol. And then you have 1 million. And that 1 million may have actually been like a deity with his hands raised, a person or a deity with his hands raised, kind of representing eternity. So they're clearly looking at the larger numbers and this number of 1 million as being symbolic of something that lasts for a long period of time, something that is large. They had a concept of eternity. They had a concept of grand things, of larger things. And it's amazing because as you deal with numbers, you're going to be dealing more and more with bigger and bigger concepts and longer ideas of time and things that you can deal with. If you read Kemetic literature, which I know a lot of you have read as I kind of look in the comments, thank you so much. Didn't they have an abacus? I don't. Somebody can tell me. Did they have an abacus? Did they have an abacus in ancient Egypt? I think they had counting utensils, but I don't know if they had something specific as an abacus. I know they had something like papyruses and like the Rhine papyrus they found. They had almost like textbooks, if you will, that scribes could use. And I'll show you an example of what that would have looked like, or something with respect to that, with respect to fractions that you could use to look at tables to help you do mathematical problems, to solve everyday real life world problems. So I don't know that Taraka, that might be something good to think about if they had that. So yeah, our ancestors are organizers and trendsetters. They very much are. Yes, they are. They're organizers and trendsetters, and we got to give them credit. If we don't give them the credit, who will? If we don't tell our children this, if we don't talk about math, it's good for us. We can't just talk about history. Not that history is not important. Obviously, I talk about history a lot, but we can't just talk about history and say that they were here or that they were black or this. We have to give our children coping tools and mechanisms to really let them understand that every aspect of human life, every aspect of human endeavor, your people were part of. People were part of. And that's one of the reasons why I think racism can live on for so long, is because people try to control information and they try to make you think that only one group of people did certain things. I remember seeing a clip of this officer, and it was something that was on the news, and it was I don't know if you remember, it was a school teacher who had been arrested. This was some years ago, and was arrested, and the police officer kind of arrested her roughly and violently and put her in the car, and apparently they had the video rolling, and she asked him, why do you harass our people? And he said, you want to know why? And he said, according to that clip, he said, because it's your people who are always doing things. Who do you see doing these types of things but your people? You see it on the news all the time. This is what you see, and that is why you get this kind of response from me, and that's why you get this response from people. And when I think about that, God bless you. Yeah, the Ashango bone. Yes, 20,000 years old. Yes, before Kemet. When I think about that, as you start, what you see is so significant. If you never see that there were black people and other people doing math before Greece was even a powerhouse, before there was even a thing of Greece, people were doing math. If we don't see there were people all over the world doing things with respect to science that literally fed into the things that we do today, that literally fed into the science, the math, the botany, the biology, the chemistry, so many things that we do today, and disciplines within math, geometry and algebra, those things were fed into by people who contributed to things all over the world. It wasn't one group of people in a very short period of time ago that just popped out and had this inspiration and never got it from anybody else. And that is important for our children to see that. We have to teach our children math. They have to see us involved in math, and they have to do math. They have to know history, but not just history. You have to know science. We have to see ourselves and yourself in every aspect of human endeavors, in technology, in medicine, in science, because we are. And if you don't have that perception, you will have that perception just like that video I told you, where the person said, I don't see it, so I don't think it's real. I don't see it, so I don't believe in myself. I don't see it because I don't think other people outside of the people we say who Pythagoras and people in Greece, nobody outside of that did anything with respect to math. We have to reject that. And we have to be the ones to say it, because they may not say it in school. We have to be the ones to put that out, because it's up to us to put the truth. It's up to us to talk about this, and to talk about this in common sense ways, and to talk about this in ways where we understand that everybody had something to do with this. Everybody contributed to this. God bless you. Mathticulous. Mrs. Gaddy, get mathticulous. Yes, there you go. Everybody had something to do with this, right? This wasn't just one group of people who had something to do with mathematics. Everybody in the world did something, because if you couldn't do certain things with numbers and math, you couldn't survive. It would be very difficult for you to live without having some idea and concept of numbers and the system and how to use it systematically. So kind of getting back to that, and talking about ancient Kemet and looking at their symbols for what was, 1,000, a million, and having very large concepts of numbers, having an idea of grandiose numbers, they applied this in very specific ways. And I want to show you ways that they applied it, but I want you to also think about, how did other people apply these things? They must have applied it if they had life, if they went fishing, if they had children, if they developed resources, if they lived, if they went to war, if they had all kinds of things that people would typically do. They had to be able to do things with numbers. If they traveled, if they looked at the stars, if they understood the cycle of the moon, they had some idea about numbers, and they did amazing things with them. So it's important for us to kind of look at that. So as we start to look at it, not only did they have symbols and hieroglyphs, as you know, they obviously also had hieratic writing. So they had demotic and hieratic writing, which is a form of cursive, which a lot of times we also don't talk about. We show hieroglyphics, but we don't talk about that they also had a cursive form of writing as well. So obviously they had a cursive form, a more friendly, user-friendly way of writing numbers. And that was very similar to their hieroglyphs, as we just talked about. So those symbols that we just talked about are the symbols they use. But we begin to look at more specifically when you start to look at how they use fractions, because that becomes significant to me. When you start to think about fractions and the manner in which they apply fractions, because you see, as we're showing here, just cattle, think about all the things you have to do in every day in a society, whether you were living tens of thousands of years ago before ancient Kemet or during ancient Kemet, just being able to eat, just being able to manage animals, just being able to manage your thing. So yes, adoration is exactly. There you go. Yeah, the and Bombo's bone really is older. Yep, is really in South Africa. The Ashangos and West African mathematicians surpassed a lot of people. We have that, right? And it's up to us. And I hear people talk a lot of times, let's talk more about West Africa. Let's talk about it and let's put it out there. Let's talk. If we don't champion, if you see something that's on your heart, that God lays on your heart, it's a fire for you. Tell somebody about it, share it, put it down in the comments below. I'll try to blow it up and share that information. Let's get this information out there so our children know. Because if we are the elders, if we are the adults, it's up to us to teach them. I had a young man in our comments one time say, I'm 18 years old, and he did this on a live that I did a little while ago. He said, I'm 18 years old, and we want to know, the younger generation wants to know where we came from. Books, please, share more information. I'm asking you to give us more information and to keep sharing, because we want to know. And I have friends, I know people who want to know more. And I thank that young person, that young man for offering his comment on the live. It's up to you and I as adults and as elders to talk about this, to think about the things that our people are doing. And to talk about this, to give the children things to understand that mathematics and science were a part of their history, and not in any spooky kind of way, not any ancient, any alien type of way, in very real humanist. These are the people who did it. Your people who look just like you and me, are the ones who did this for long times ago, for many thousands of years ago. So as we stop and think about that, and we start to go back, what types of things would you have to do if you were in a society? Well, you had to manage cattle, right? You had to be able to manage the resources that you had, because if you were a person who had cattle, or maybe you even had dogs, you may have had other animals that were domesticated. If you lost some, well, that would be a big problem to you, right? Imagine going out and you have a huge herd of cattle, and you were rich, or maybe you were not so rich, and you had a lot of resources, or not so much, and you lost a certain percentage of your livestock. Well, that would be a problem. So you probably wanted to count them. We don't even think you probably counted them. You probably went every day out. If you were a shepherd, if you were leading these animals that were important to your survival, you probably counted them every day. Whether we want to say it or not, whether you kept it in your head, you had to keep track of how many you had, because that was important to your survival, or somebody could take one, or one could die, or one could wander off, and you won't even know how to manage your resources. And pretty soon you wouldn't have any if you didn't know how many you had every day. Imagine that, the whole simple things of that. And even in ancient Kemet, beyond just managing livestock and cattle and things of that nature, they had to look and measure the rise and fall of the Nile, because how high, they literally have measuring sticks, which is a form of math, guys, and a form of science. measuring sticks, and they had measuring units, a cubit or however you like to look at it. They had measuring units to measure how high the floods were going to now, because that would determine basically their harvest and how the season would go, and whether or not they would be hungry. They had taxes that they had to pay. They had people who were literally governors over areas who collected taxes, which were in the form of resources. It might have been barley or various things you had to pay either into temples or into the king as a part of your taxes and a part of the tax system. All of that required mathematics. All of that required math, not to mention the building of the temples, not to mention the building of the pyramids and various things. You needed math to operate as any society, whether it's a complex society or even a simple society or just a family, you need math. So they were doing that tens of thousands of years ago, before ancient Kemet and during ancient Kemetic time. So you start to think about that. You have accounting, you have administrative things, you have basic livestock and basic needs you have on a day-to-day basis. You have communications with other kings. You have buildings that you're building. You have war that you're going to. Imagine you went to war in what is today southern Syria, because ancient Kemetic people did that, quite a bit. They went to war in places, beyond their borders and they expanded their borders. Imagine you went to war, many, many miles away from where you live in a place like southern Syria, and you didn't bring enough resources. You didn't bring enough food. You didn't have enough weapons. You didn't have enough resources to conduct the war that you needed, or to conduct the siege. You'd be in trouble. You had to plan for that. It's silly for us to think that the first people to do mathematics were people from a certain part of the world, and it was Greeks, and that was it. That's silly. There's no way they went to war in places like Syria and various places like that without planning, without doing mathematics, without having a systematic way to do that. And we must teach our children that, and we must use our own common sense as we start to do that. So the human calculator that surpassed Newton, I don't know if anybody knows that the name of the human calculator who surpassed Newton. Grain houses are prominent in history. You're right. So, ancient Kemet wasn't the only place that had grain houses. They weren't the first places to store. If you look at ancient Kush, and you look at even Nabta Playa that we've been talking about, which is 5000 BC, you find villages and settlements with storehouses. They had like store pits. They would have, areas and storage areas they would dig into the ground to store resources, that they needed to survive. So it isn't just one group of people. I'm saying math is essential to a society. It's essential to anybody's life. And if you want to survive out on your own in the open fields of Africa or wherever you might be, you're going to need to have math in order to survive. You're going to need to apply numbers in some kind of way in order to survive. So I think that is very significant. So I want to show you, kind of get back to looking at the manner in which they use fractions. Look at another specific example of the way the Kemetic people approach fractions, and I'll kind of close this here so you can kind of see it. One of the things that they did was they used unit fractions. So when I say unit fractions, what does it mean for a unit fraction? Instead of just looking at the word, like at the fraction 3/4, they typically a lot of times would write fractions in terms of one being the numerator and it having a different denominator. So if you look at one as a numerator, you're really looking at a single unit of this whole, right? So if you think back when you were in elementary school and you had fractions, you maybe had something cut into 2 parts or something cut into 4 parts, and you had to shade one area of that, and that would be one unit of it. Well, that's how the ancient Kemetic people typically wrote. They looked at units of fractions, and they typically had one as being the numerator. And we can look at that because we can see their math. So they look at it from a unit perspective. So they had an interesting way of doing it. So if you had a number like 3/4. 3/4 wouldn't just be, 3/4 or 1/4 plus 2/4. They would write it as 1/2 plus 1/4. Because if you start to figure this out, you deal with it, especially if you're visual, you can clearly see that 3/4 is equal to 1/2 plus 1/4. And I'll show you an example of that. How would they know that? And how would they represent that? So let's take an example right here. Let's say we had the number 2/3 right here. We're looking at 2/3. And you can just they very quickly begin to understand that you can take a whole and break it up to however many equal parts you need to. And that puts you in so much of a freedom when it comes to math. You are able to apply this in a lot of different segments in a lot of different ways. You take up a whole and you can cut it up in any different even ways that you want to cut it up. So it doesn't matter if I'm dealing with 2/3 of this or 3/6 of that or 5/6 of that. I'm going to imagine I'm dealing with a whole and I'm just dealing and cutting it up in different ways. And I can then therefore do special things with math if I understand that. Let me explain that. So let's say we have had the number 2/3. And I'm looking at this rectangle here figure, and it's cut up in 1/3, 1/3, 1/3, right? So I can look at this, and if I wanted to say, what is 2/3? What is something that's equal to 2/3? How would I write 2/3 from a Kemetic standpoint? If I look at this, I look at the same length, if you will, of a whole. And instead of it being cut up into 3 equal pieces, I have it cut up into 6 equal pieces. So this is 6 equal pieces. I can easily look at that and say, you know what? 1/2 of this whole, if it's the same thing as a whole, 1/2 of this is part of this, is going to make up a big chunk of this 2/3. If I wanted to see what is this equal to in terms of 2/3 of this, 1/2 of this bottom is equal to a big chunk of this 2/3. And what would I have left over? If I took 1/2 of this, right, I would have 1/6 of this chunk, if you will, left over. And this whole entire thing would equal my 2/3, would be the same as the number on top of that. That's literally how they looked at it. That whole entire thing would be really those 6 cut up would equal that part of that 2/3 up top. And so therefore they would write the number 2/3 as 1/2 plus 1/6 is equal to 2/3. That's how they did it. 1/2 plus 1/6 is literally equal to 2/3. And you can look at the numbers right there and you can see that 1/2 of this, which you can put 1/2 and now have 1/6 left over, will be equal to 2/3 of the same thing, just cut up in a different way. And so when you did that, if you had to do that math on your own, if you had to do it the way we do it now, you would come up with the exact same answer. You would just try to find a common denominator on the bottom. You would multiply this times 3 and you would get 3 over 6, if you will, and you end up getting 4/6. And when you reduce that, you'd end up getting 2/3. You'd end up getting the same answer that we would get today using the mathematical approaches that we use today. But that's how they would do it back in ancient Kemet. They would basically look at the fractions and be able to write them in terms of unit fractions and be able to see how much of a certain segment of a fraction of one piece, if you will, would be equal to another piece if it was written or broken up just in a different equal pieces. And that to me is just, it's a different way of looking at math, right? And it's not wrong. Obviously they came with the right answers because they applied it. It's not wrong. It's a different way of looking at math. And the beauty of that, when I see that, when I see that, the beauty of that is that you have a different way of, you look at a different perspective. When you start to think about ancient Kemet, you're starting to think about that there are different ways of looking at the same problem. There are different ways of looking at science. You know, one person's way is not the only way to do it. We know that. And if we ever met people from other places or people from, whatever, people from other planets, they're aliens, whatever, if we ever met people, we would probably find that they have different ways of doing the same thing. And it's true on Earth. It's true here. There are people who have, and even in antiquity, who have different perspectives on math, different perspectives on how to use fractions, different perspectives on religion, different perspectives on geography and botany and biology. And that's the beauty of it. Because if you just take one person's approach, you're going to end up finding yourself where you're missing out on a lot of important information, because a different perspective can sometimes show you things that you never know, show you things you never knew. And when we look back in antiquity, that's what our ancestors give us. We need to stop thinking that other people who did math or did history in certain ways, that somehow they were not as significant or as important as some of the things that we're taught in school or in education, because they just had different value systems. So I don't care if you were talking about people who were in North America and South America, tens of thousands of years ago, Native Americans who would have looked at mathematics and the world and their environment and their lives with a different value system. That to me jumps out. It's not that one way is better than the other. It's that the people value different things. In ancient Kemet, they valued the afterlife. They valued their relationship with God. They had different value systems which colored their approach to the different human activities that people would have. In Europe, they had different value systems. In Greece, they had a different value system. In Southern Africa, we look at some of the Ishango bones in Congo and various ways, there would have been different systems and a different way of looking at the world that was important to them. And I think that's important for us to recognize that in everybody and to take that into account and to value that in terms of that the way people present that information. So I just wanted to share that. I hope you put more of your comments down below. I love reading them. God bless you. We're going to talk more about this in the future. Please share this with somebody. Like this and share it with somebody. And I'll talk to you soon. Thank you so much for watching and for listening.